In this video, we will introduce briefly beta distribution and then show how to use beta distribution functions in Python. So the beta distribution is a family of a series of continuous probability distributions defined on interval 0 and 1, and with two positive parameters called alpha and beta. So called alpha is shape and beta is scale parameter. So beta distribution basically shows the probability of probabilities. So because the random variable in beta distribution is only available between 0 and 1. So it is perfect to use beta distribution to model, for example, as a prior distribution in Bayesian statistics. Because beta distribution is also conjugate with the Bernoulli binomial, negative binomial, and geometric distributions in Bayesian inference. So this figure shows several beta distribution density curves with different alpha and beta. So before we can understand the distribution density function of beta, we have to know something about called beta function. So this is a beta function. So beta function is an integration of the value between 0 and 1. And the integration's form is x alpha minus 1 power times 1 minus x beta minus 1 power. And this formula is also equals gamma alpha times gamma beta divided by gamma alpha plus beta, where gamma is a gamma function. So the gamma alpha is integration from 0 to positive infinity with x alpha minus 1 power times e minus x power. So then we can see beta distribution density function has a form like beta function of alpha beta, then 1 divided by this beta function, and times x alpha minus 1 power and times 1 minus x beta minus 1 power. So this density formula for the x variable between 0 and 1. So for the other x values, its density is 0. So beta is only available for the random variable between 0 and 1. And note that the uniform distribution we have learned, for example, uniform between 0 and 1 is a beta distribution with parameters alpha equals 1, beta equals 1. So the mean and variance of a beta distribution with parameter alpha and beta are mu equals alpha divided by alpha plus beta, and sigma square equals alpha beta divided by alpha plus beta square times alpha plus beta plus 1. And uniform distribution on the value between 0 and 1 has mean and variance equals 1 of 2 and 1 of 12. So in Python, if we want to use beta distribution, normally there are 4 functions in module scipy.stats beta. So we have to first import scipy from scipy.stats, import beta module. Then beta modules have 4 functions. PDF is probability density. CDF is for cumulative probabilities, and PPF is for quantiles. And PPF is the inverse operation of CDF. And RVS is for the random number generation. So next we will show several examples using these functions in Python. So first we import data from scipy.stats and import numpy and import matplotlib.pyplot. So we first show how to use beta density function. We create an empty array, with the value between 0.01 to 1, and with the gap 0.1. So this array called quantile represents the beta variables, because beta variables between 0 and 1. So we use very close to 0 to 1. So next we set A and B representing alpha and beta both equal to 1. So this actually is a uniform distribution. So we can use beta.pdf to calculate the density value associated with this beta variable called quantile with alpha beta parameter. So next we will plot this curve between the quantile, the beta random variable, and its density. So you can see this density function is actually uniform density between 0 and 1, and the area under this curve between 0 and 1 equals 1, because the probability, total probability and the density curve will equal 1. So 1 times this length 1 equals 1. Next we will set another alpha and beta value with 2 and 2. Then also run the same function for the density of these random variables with new A and B representing for alpha and beta, and plot the curve between quantile, beta random variable, and their densities. So this is the new curve for beta density with alpha, and for the beta curve with alpha and beta both equal to. You can see the density highest is about 1.5, and the x value between 0 and 1. So the area under the curve is also close to 1. So next we will show a function will generate cumulative probabilities. So first we create quantile same as before, and A and B both equal to. Then we use beta.cdf to calculate the cumulative probabilities of this value with alpha and beta. And similarly we plot the curve between quantile value, random variable, beta random variables, and their cumulative probability. So the cumulative probability, of course, is an increasing curve from 0 to 1. And next function is called quantile. Usually we call it quantile function, which is to calculate the quantiles, to calculate the beta random variables from given cumulative probabilities. So this is cumulative probabilities. So actually, this operation is the inverse of the cumulative probabilities. So cumulative probabilities we have seen is to calculate the cumulative probability from the beta random variable. And here we want to calculate the beta random variable from the given cumulative probabilities. So we create an array called probabilities, also between 0 and 1, with the gap 0.1. And we set A and B, alpha and beta, both equal to 2, same as before. So next, the function is beta.ppf, which is used to calculate the quantiles or calculate the random variable values based on the given probabilities. These probabilities is the cumulative probabilities from 0 to 1. And next we print the curve between probabilities and cumulative probabilities in the x-axis, and the calculated quantiles random variables in the y-axis. Show how it is going. So this is also non-negative, non-decreasing curve. So for example, 0.4, which means the probability, cumulative probability, 0.4, the value is about 0.45. So which means for the probability of x less than 0.45, the probability is 0.4. Or we say about 45%, or we say about 40% of the values of random variable in this beta distribution under the value 0.45, right? So about 40%, because the probability, cumulative probability is 0.4, so we can 40% of values in this beta distribution has a value lower than 0.45. The last function in the beta distribution in Python we will show is generating random variables in a beta distribution. So we set, for example, beta distribution with alpha and beta 6,2 here. Then we use the function called beta.rvs random value, RVS AB, and size with 10, which means we want to generate 10 such beta random variables. Next, we will show these 10 numbers. So you can see all values between 0 and 1. 0 and 1. Thanks for watching.